Good morning, friends. In this section, we will discuss about the basic transmission line equations. In our previous section, we have discussed regarding to the transmission line and the basic parameters of the transmission line which are existed in that. Now, we are discussing about the basic transmission line equations. So before going to that, first of all, I am giving the basic structure of the transmission line with the primary constants. Here we know that simply the basic transmission line will be seems like this with four elements R, L, C and G. These are the four constants, primary constants we are having with the basic transmission line. Here it is R, L, C and G. Now it is the input. At the input section, I am assuming voltage as V and current as I. It is the output section. At the output section, I am assuming voltage as V plus dV and current as I plus di. I plus di. Yes, I am assuming like that. Here, when we observe this, here we are having there R and L are in series. R and L are in series. So now I am writing that series impedance, that is series equivalence impedance with these two. With these two I am writing as R plus J omega L. It is called as series impedance. Now C and G are in parallel. So I am writing the shunt admittance. With the combination of these two, shunt admittance can be written as C G plus J omega C. It is the shunt admittance. Now this is the simple structure of the basic transmission line. Now I am applying KVL. I am applying KVL for the input loop. So simply apply KVL for input loop. For this one we have to apply it. Simply we know that the existence of KVL, that is applied voltage is equal to drop of all individual voltages. Now here applied voltage is V minus, here the current flowing through this series impedance is I into R plus J omega L into dx. Here dx is nothing but the transmission line, a piece of transmission line we are having, that is dx into dx minus V minus dV equal to 0. Here this one will get cancelled. Now I am letting this dV to this side. So dV is equal to minus I into R plus J omega L into dx, and I am taking this dx to this side. Then dV by dx equal to minus I into R plus J omega L. Let it as equation number 1. Equation number 1. Now in the second step, apply KCL at this point P. KCL at this point P. That is the second step. Apply KCL at point P. At point P, I am applying KCL. Now here, by applying KCL at that point, I minus di, that is simply for this point I is the incoming current and outgoing currents are I plus di, and at the same time the current flows through this shunt admittance. So here incoming current, that is I, minus outgoing current I minus di, minus V into G plus J omega C into dx equal to 0. That is simply, here I is the input current and I minus di is the current flowing through this one, and V into G plus J omega C into dx is current across this shunted. So with this I will get cancelled. Then I am taking this di to this side. So di equal to minus V into G plus J omega C into dx. And by letting this dx to this side, di by dx equal to minus V into G plus J omega C. It is equation number 2. Like this, we are having equation number 1 and equation number 2. Now consider equation 1. Consider equation 1, that is this equation we had to consider. Now consider equation 1. The equation 1 is here, dV by dx equal to minus I into R plus J omega L. So dV by dx equal to minus I into R plus J omega L. That is equation number 1. Now for this equation, I am applying differentiation for both sides. I am applying differentiation for both sides for above equation. Then it will becomes dV by dx. By applying the differentiation for this dV by dx, we will get d square V by dx square equal to here this one, that is R plus J omega L into, for making differentiation for this I, we are getting di by dx, minus value. So where there is d square V by dx square is equal to minus R plus J omega L into, from equation 2 we have some expression for di by dx. Di by dx equal to minus V into G plus J omega C. So I am substituting this value here. Instead of this one, I am substituting that value. That is di by dx equal to minus V into G plus J omega C. That is the value of di by dx. Now d square V by dx square is equal to minus into minus. It will become plus V into R plus J omega L into G plus J omega C. j omega c. And I am writing this d square v by dx square equal to gamma square v. Here the value of gamma is, here gamma is equal to square root of r plus j omega l into g plus j omega c. That means this value I am writing as a gamma. So I am writing here as d square v by dx square is equal to gamma square v. Write it as equation number 3. Equation number 3. Now I am repeating the same process for equation number 2. That means from equation 2 we have from equation 2, here is equation 2, this is the equation 2, dA by dx equal to this one. So I am writing here from equation 2 we have di by dx equal to minus v into g plus j omega c. That is equation 2. Again I am repeating the same process. Differentiate with respect to x on both sides. So by making differentiation here, d square I by dx square equal to minus dv by dx into g plus j omega c. And now I am substituting this value dv by dx value I am substituting, that equal to the value of dv by dx is here minus I into r plus j omega. So d square I by dx square equal to minus I into r plus j omega l, and already here have some value g plus j omega c, So with this d square I by dx square is equal to already minus values here, minus into minus plus, then I into r plus j omega l into g plus j omega c, and this can be written as d square I by dx square equal to gamma square I. Here again the value of gamma here, gamma equal to square root of r plus j omega l into g plus j omega c. That is the value of gamma. So for this, then let it equation number 4. Now look at here, equation number 3 and equation number 4. These two are linear differential equations. That is equation from equation 3, d square v by dx square equal to gamma square v, and from equation 4, d square I by dx square equal to gamma square I. Here these three equations are linear differential equations. Then the solutions for the above equations can be written as v equal to vf into e power minus gamma x plus vr into e power gamma x, and I equal to if into e power gamma x plus IR into e power gamma x. These are the solutions for this above equation, and these are called as basic transmission line equations. Here VF, VR, IF, IR are the arbitrary constants, and the value of gamma is a complex quantity, and it can be written as gamma equal to alpha plus j beta. Just substituting this value in above equation, V equal to Vf into e power minus gamma is nothing but alpha plus j beta into x plus Vr into e power alpha plus j beta into x. Similarly, I equal to If into e power minus alpha plus j beta into x plus IR into e power alpha plus j beta into x.